Hi and welcome to video 16 of my differential equations series from topic 2, unit 4, specialist mathematics. In this video we're going to talk about differential equations using definite integrals. So when it comes to solving differential equations, we're often given enough information to find our C value. Remember, when we solve a differential equation we integrate, which provides us a C value. But we also might want to then use that equation, use that value to find something else. So we could use integration instead, where the C value is irrelevant, to find the integral between 2 points, and that will also give us the something else that we want to find in some cases. You can see what I've written in purple there. In my humble opinion, it's a minor thing, an unlikely occurrence that you have to do it this way. When I say unlikely, it's not really mentioned in the syllabus, but we use the Cambridge textbook, so we're just making sure you've seen this, if you like, and I want to make sure that you've seen what they do in the book, and that it's not a question that you therefore have. So I'm going to do one example with you, and we'll talk about the traditional way, and then we'll talk about the definite integral way, and then maybe you can have a go at a couple of questions. So determine the value of y. So this is use the solution of the differential equation at x equals 5 to this differential equation, which is a pretty simple one, given this information, which is our information to find c. So here's the traditional way first of all. In the traditional way, we solve the differential equation first. dy dx is equal to 2e to the x plus x, and so therefore y will be equal to the integral of 2e to the x plus x dx, and that means that y is equal to 2e to the x plus a half x squared plus some c value. Now we know that at x equals 1, y equals 2e. It's like magic e's here. So we get 2e is equal to 2e to the 1 plus a half times 1 squared plus c. And if we solve and rearrange this, the 2e's cancel out, by the way, we get c is equal to negative a half. And so now we've got c is equal to negative a half. That leads us to the fact that y is equal to 2e to the x plus a half x squared minus a half. So that's nice. Now we can work out at x equals 5, y is equal to 2 times e to the 5 plus a half times 5 squared minus a half. Things aren't quite as nice this time. I can write it down as 2e to the 5, 12 and a half minus a half, so plus 12. And I could work out what that's equal to, but e to the 5 is pretty big, but anyway, there we go. Now, with definite integrals, we start with our function, dy dx is equal to 2e to the x plus x, but we have boundaries and we have known values of boundaries. So we can write down that y is equal to the integral between 5 and 1 of 2e to the x plus x dx. It's pretty close to what we're going to do, but what we need to recognize now is that this integral represents, and I've written this in green, it represents the change, the actual change across the function from 1 to 5. So if we want to know the value when x is 5, we need to work out the value between 1 and 5, but just add on the value at 1, which is 2e. And that will be an important feature. And it's interesting because there's a relationship with c here. You see this sort of 2e pop up here in our original answer as well. But we add on that 2e because then 2e, which is the value at 1, plus the value of 1 to 5 will give us our value at 5. So we go through and we do the definite integral. We get 2e to the x plus a half x squared. We don't have to worry about c in this case, between 5 and 1. And that gives us 2e to the 5 plus a half 5 squared minus 2e to the 1 plus a half, and then plus 2e, and of course the 2e and the 2e here cancel out, and that gives us 2e to the 5, a half 5 squared is plus 12 and a half, and then minus a half there, and that gives us 2e to the power 5 plus 12. And would you believe it, That is exactly the same as the answer we got here. So you could use definite integrals if you have an understanding that the integral represents the change in the function between two values, and in this case that's helped us to answer this. And you know, some people would argue a bit quicker, but I would say if you can do it this way, I really can't see why you'd have any problems, but that is something for you to consider. All the best.